So we're going to look at Maclaurins expansion in this video, and this formula here that you can see on the page, this is from the formula booklet that the IA give you, and this top one I'm just going to put a circle around now. This is Maclaurins expansion, and they give us 1, 2, 3, they give us 5 that are already done for us. So the general ones we don't have to remember, but what I'm going to do is I'm going to show you exactly how we get this sine x one here. So we're going to start off with fx is equal to sine x, and the first thing we need to do is to find out what f0 is, and f0 is sine 0, gives me nothing. I'm now going to differentiate the term, so f dash x is going to give me cosine x, and then what I do is into that I put 0 again, so cosine 0 is 1, and I keep going. I'm going to differentiate for the second time, and when I differentiate cosine x it gives me negative sine x. I put 0 in again, and that gives me nothing. Differentiate for the third time, and when I differentiate for the third time I'm going to use little x up here. Negative sine x goes to negative cos x, and f3, and again I put in 0. This time it gives me minus 1. I do it a fourth time. Now you'll have to keep going to the fourth or fifth one. This comes out being a bit of a pattern because negative cos x sends me to sine x when I differentiate it, and f40 is back to 0. Now what I'm going to do is I'm actually going to put in like each part here just to explain it in depth. When we make the expansion, we do 1 times f0. That's what that means here, f0, and we times it by 1. So we've got 1, and f0 is up here, which is 0. Then we have x times f dash 0, which is there, which is 1. And then we have x squared over 2 factorial, and we times it by the f2. And we just keep going with that pattern. So the next one is x cubed divided by 3 factorial, and this is times by negative 1 because we're looking for the 3, and so on. So the next one will be x to the power of 4 factorial, and this becomes 0. And we can keep going with that. So this then ends up being 1 times 0 is nothing, so we don't even include that. Then we start off with an x. Nothing for the next, this term here becomes nothing because of the 0. The next term becomes negative x cubed over 3 factorial. Then we have a 0. Now the next one is going to be a positive. Even though I haven't written it there, I know that the expansion is going to give me 1 because it sends me back to f5 is going to give me 1 because f5 is the equivalent of f1. This pattern starts repeating itself. Because it starts repeating itself, there's no x to the power of 6, but there is an x to the power of 7 over 7 factorial, but that's going to be a negative 1. So you can see how this pattern is developing out like this, and so on. And as you can see, the first part of that expansion right here is the first part of my expansion. Now, just as a tiny bit more of an extension to that, what we're going to do is we're going to expand or do a Maclaurins expansion for sine 3x, and I'll do it down here, keeping it on the same page, but I'll just do it in a different colour. So sine 3x, we don't need to go through that whole expansion again for each one. What we're going to do is we're going to take this expansion that we've got above, and we're going to replace the x here with 3x. So it becomes 3x minus, then we're going to do 3x cubed over 3 factorial plus 3x to the power of 5 over 5 factorial. So you can actually just substitute in any particular values you have into these common ones from the formula sheet. So when I just do that, this gives me 3x, and this is going to give me minus 27x cubed over 3 factorial is 6, and you can simplify that, plus 243, I think, x to the power of 5, and 5 factorial is 120, and then we take away 3 to the power of 7. You might need to check this. 7 factorial is 5040. So once we have these basic Maclaurin series expansions, we can substitute in to make much more difficult ones.